NASA's James Webb Space Telescope just keeps on delivering amazing discoveries. Discoveries that would make Isaac Newton and his whole posse of discoverers eat their hearts out, that's for sure. Back in July, this telescope observed the exoplanet WASP-39b and found fingerprints of atoms and molecules and active chemical reactions in its clouds. It's approximately 700 light-years from Earth, which means if there were any aliens there, it would take us millions, if not billions of years to catch the very first whiff of their farts. We may not even be around by then. On a more serious note, WASP-39b is actually a gas giant with a mass almost equal to that of Saturn and no surface. Therefore, that alien thing, not very likely, gassy or otherwise. The July observations were pretty exciting. The results give a much clearer and richer understanding of the planet's thick atmosphere. For starters, the atmosphere contains a great deal of sulfur dioxide, which means this bad boy would give Venus one hell of a run for her money in the stinky rotten eggs department. WASP-39b is not exactly an Earth-like planet. It lies closer to its G-type star than Mercury does to our Sun, and orbits once every 4 Earth days. The planet turns out to be quite a puffy world, like cheese puffs, largely because it's hot, about 871 degrees Celsius. Like cheese puffs in a melting furnace, JWST tracked the planet as it passed in front of its star. Starlight filtered through the atmosphere, and different gases there absorbed different colors of the starlight spectrum. This is how water was detected at WASP-39b. Same with sulfur dioxide, carbon monoxide, sodium, and potassium. Gee, I hope that's not how cheese puffs were discovered. No, cheese puffs were not discovered. They were invented. Yeah. What does the atmosphere tell us? Now that astronomers have a good inventory of chemical elements at WASP-39b, they also see how abundant each chemical is in its atmosphere, giving us precious information about back when all hell was breaking loose. Among other things, it gives us clues to conditions in the disk where the planet, its star, and any other planets formed. In fact, the gases in WASP-39b's atmosphere provide hints about a history of all kinds of crazy shit happening, like smash-ups and mergers. Kinda like the formation of our very own good old solar system. The abundance of sulfur relative to hydrogen indicated that the planet presumably experienced significant accretion of planetesimals that can deliver these ingredients to the atmosphere. The data also suggests that the oxygen is a lot more abundant than the carbon in the atmosphere. This potentially indicates that WASP-39b originally formed far away from the central star. WASP-39b results hitting the press. The survey of atmospheric chemistry that JWST performed is the subject of 5 scientific papers in review and publication. They contain some pretty amazing revelations. This is the first time we see concrete evidence of photochemistry, chemical reactions initiated by energetic stellar light on exoplanets, said Shangmin Tsai, a researcher at the University of Oxford in the United Kingdom and lead author of one of the upcoming papers. He went on to say, "I see this as a really promising outlook for advancing our understanding of exoplanet atmospheres with this mission." The precision with which the James Webb could detect so many atmospheric signatures bodes well for future exoplanet studies. This is particularly true as astronomers hunt for planets where life might exist. Their atmospheres will contain chemical clues that point to that life. We are going to be able to see the big picture of exoplanet atmospheres, said Lara Flagg, a researcher at Cornell University and a member of the international team. She went on to say, "It is incredibly exciting to know that everything is going to be rewritten. That is one of the best parts of being a scientist."